Stratospheric ozone depletion. The introduction of chlorofluorocarbons, CFCs, and hydrochlorofluorocarbon, HCFCs, has dramatically changed our lifestyles. ASHRAE safety ratings do not consider the environmental effects of a refrigerant. Little did we know that the use and release of these compounds into the atmosphere would have far-reaching and long-term effects on our environment. The greatest effect occurs in the stratosphere, which is very far from the Earth's surface. The stratosphere, located between 7 and 30 miles above sea level, is made up of ozone and other gases. The ozone layer is the Earth's security blanket. An ozone molecule, O3, consisting of 3 oxygen atoms, protects us from the sun's harmful ultraviolet radiation and helps maintain the Earth's stable temperature. Stratospheric ozone depletion is a global problem that can lead to problems such as crop failure, skin cancer, an increase in eye diseases such as cataracts, and a reduction in plankton and other microscopic marine life. CFCs, chlorine, fluorine, and carbon, and HCFCs, hydrogen, chlorine, fluorine, and carbon, have been found in air samples taken from the stratosphere. When CFCs and HCFCs are released into the atmosphere, their chlorine content causes ozone layer depletion. When a chlorine atom encounters an ozone molecule, it takes an oxygen atom from the ozone, which forms a compound called chlorine monoxide, CiO, leaving behind an oxygen molecule, O2. Chlorine monoxide will collide with another ozone molecule, releasing its oxygen atom, forming 2 O2 molecules, leaving the chlorine free to attack another ozone molecule. A single chlorine atom can destroy up to 100,000 ozone molecules. There has been some controversy over the issue of ozone depletion. Some believed that the chlorine found in the stratosphere comes from natural sources, such as volcanic eruptions. However, air samples taken over erupting volcanoes show that volcanoes only add small amounts of chlorine to the atmosphere, compared to the amount of chlorine added to the atmosphere from chlorine-containing refrigerants. The evidence is clear. Chlorine-containing refrigerants have changed the natural balance, thereby depleting the ozone layer. Unlike other chlorine compounds and natural chlorine, the chlorine in CFCs and HCFCs does not dissolve in water or break down into compounds that dissolve in water, so they do not leave the atmosphere. HFCs are made up of hydrogen, fluorine, and carbon. They do not contain ozone-depleting chlorine, but most HFCs have a high global warming potential, GWP. Ozone depletion potential, ODP, is a measure of a substance's ability to destroy ozone and ranges from 0 to 1. CFCs have the highest ODP. HFCs are 134A, are 32 and 400 series hydrofluorocarbon blends, and HFOs are 1234YF, 1234ZE, and 1233ZD hydrofluorolefins, contain no chlorine and have an ozone depletion potential of 0. Greenhouse gases warm the Earth in 2 ways: absorbing energy, reducing the speed at which it escapes into space, and acting as a blanket, insulating the Earth. Examples of greenhouse gases and their effects on the atmosphere are the following. Carbon dioxide, CO2. CO2 is a natural gas, created by respiration and absorbed by photosynthesis, a relatively balanced cycle. The man-made addition of CO2 creates in certain chemical reactions, such as the manufacture of cement. Carbon dioxide is used as a very high-pressure refrigerant, R744, and with a global warming potential, GWP of 1. R744 is primarily used in commercial and industrial process systems. Natural refrigerants such as R744, carbon dioxide, that do not pose a health or environmental threat, according to the EPA, can be returned to the environment. Flammable refrigerants. Equipment with flammable refrigerants requires a red marking on all process tubes, service connections, and piping through which a flammable refrigerant passes. The color marking must extend 1 inch in both directions from the service locations. When propane R290 is used as a refrigerant, it must meet purity standards established for HVACR equipment. Propane purchased for grilling contains impurities that will damage refrigeration equipment. Propane and isobutane are examples of A3 flammable refrigerants that do not require recovery. Propane, butane, and other hydrocarbon refrigerants are also known as HC refrigerants. Fluorinated gases. Hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride, and nitrogen trifluoride are synthetic, powerful greenhouse gases that are emitted from a variety of industrial processes. Fluorinated gases, such as CFCs, HCFCs, and HFCs, are called gases with a high global warming potential, high GWP gases. R410A. Hydrofluorocarbon is a high-pressure HFC refrigerant with an ODP of 0, and a global warming potential, GWP 2090 times greater than carbon dioxide. R410A is a near-azeotrope refrigerant that does not fractionate during phase change in HVACR equipment. A disadvantage of R410A is that the operating pressure is approximately 50% higher than R22 and cannot be considered as a replacement for retrofitting existing systems. R134A. Tetrafluoroethane is an HFC with a 0 ozone depletion potential, ODP, and a global warming potential, GWP 1430 times greater than carbon dioxide. R134A is a mid-range pressure refrigerant used in the automotive, home refrigeration, and commercial industries. R1234YF. Tetrafluoropropene R1234YF is a medium-pressure HFO refrigerant with an ODP of 0 and a global warming potential, GWP, only 4 times higher than carbon dioxide.